Okay, people have been asking for a video to show how to assemble the THB6064 driver, so that is what we're going to do today. I'm going to pull up the instructions on my computer. You would normally have a little printed out sample of this web page, but it's exactly the same information. I mean, if you don't have the instruction manual or you don't like reading off the paper, just go to the website and start there. The first thing is to just go ahead and open up the little package here, and you will notice that all the parts are inside, especially these two little surface mount resistors are taped to the side of the package. You've got your circuit board, chip. The chip may be, so for example, if you order 3 of these, each one of these bags will have the parts for one driver in it, and then there may be a stick like this with 3 chips that are sent separately, then instead of each chip being included with each bag. Okay, so don't freak out if the chip's not in the bag. Look in the box, you'll probably find that it's there. And then a series of other components. Most of these are pretty standard, pretty easy to assemble capacitors and resistors. There are these little jumpers that you want to make sure you don't lose. They're pretty tiny. 5 of those. And then you can just kind of stage your parts. Here's your network resistors. Those are all 3 the same. Here's your big capacitor. Here's your medium-sized capacitor. And here's your string of 5 very, very small capacitors. And here are the 3 medium small capacitors. That's just the appearance of the current components, okay, so we may change those. For example, the last time I ordered these particular guys came in blue, okay, so don't be surprised if your components look a little bit different. We've got a red LED and a green LED, and then we have a couple of terminal blocks here, the little standard step direction power and enable connector, PN-in-MO connector, the current level adjust resistor, and excuse me, last but most confusing, all of the resistors. Now, the most common error I have found in building kits, at least for myself, and I think for most people, is putting the wrong resistor in the wrong place. And it's especially confusing in this kit because there is a mix of 5% and 1% tolerance resistors. Some of them are more higher tolerance than others. So you get some with 4 bands and some with 5 bands. And it's just difficult to know which is which. So here's my very, very, very strong suggestion, is that you just take them all and lay them out on a piece of paper like so. Tape down one side like that. Grab your handy dandy multimeter, which of course everyone building intermediate level kits should have, and then just go down through each one, measure what the resistance is, and write that down right next to the resistor. Let's see, maybe if I place this over here, it'll be a little bit easier. Just a couple of quick things about measuring resistances. Whenever you're doing that, you want to make sure that you're not touching the actual metal part of the lead, because obviously that would give you the resistance of both your finger and the resistor, and not just the resistor. So that is obviously a 47K resistor. So I'm just going to write down here 47K. Okay. And this guy is a 4.7K. The other way of writing that, by the way, is 4K7. Okay, pardon my horrible writing. But if you look on the actual silk screen of the board, what you will see is that, I'm trying to make sure that that's visible, that in those cases where we have something that's like, for example, 4.7 K ohms, we've written it as, right here, well that's a 47K, excuse me, so here's a 2.2K, and we've written it as 2K2. The K just replaces the period. So that makes it always 3 digits long, makes it very easy to fit onto the board. Okay? So then continuing on with these, we have a, see what this guy is. Let's see, what is that? 2700, so 2700 ohms. So 2.7K, or 2K7. And then, oops, don't lose the parts. I may cut this part out of the video because it's not exactly scintillating. Okay, here's the 2K2. I hope you can see that meter screen just a little bit. I want you to understand that when you measure a 2K2 ohm resistor, you might see something like 2194. Okay, 2194 ohms. Well, that's pretty close to 2200 ohms or 2K2. Okay, so then this one here is, I think that's supposed to be 470. My goodness, 460 it is. So you see that's a low tolerance resistor. And then we have 330 there. Pretty sure that's supposed to be 470, but close enough. So now once we have all of those measured, there is no chance that we're going to mess up and put them in the wrong place. Which is very important. So moving forward, there are some standard rules to the assembly of any of the boards that I sell, or any well-made board actually. Whenever you have a polarized component, the positive lead should always have a square pad. Hopefully you can see that. Got the nice big capacitor there, and the positive lead is going to go in the square pad. Okay, pin 1 on any IC will always be the square pad. So you'll notice that, for example, up here, one of the pads is square. Okay. I recommend very strongly that whenever you're soldering a component onto the printed circuit board, with the possible exception of this capacitor, that you leave a little bit of lead space. So let me just give you an example of that. On this particular board, there are two different options for the error indicator. Now, the supplied option, and the one that's recommended, has the error LED going right here in this space. Okay. A lot of people end up making the mistake of putting it here next to the LED that says error, thinking that they're not reading the directions and they're just building the board according to what's there. Instead of putting the LED in like that, where it's right up next to the board, I always recommend that you put it right there. I don't know if you can see on the leads, but there's a spot right there where they are indicating a little bit of a relief. That's where they intend, the manufacturer intends for the LED to be installed at that location. So what I do is recommend putting it into that location, and then you once you're at the right place, you just bend the leads out away from each other, and then when you solder it upside down, you will have it at the right location. Okay? We'll put that guy in a minute. But that's just an example. So always please leave a little bit of lead length. The possible exception to that would be, the big capacitor. When you install him, if you want to snug it all the way down, then fine. That's certainly understandable. Some people may wish to install this capacitor, as I am going to in this particular case, not vertically, but instead like this. And there's a reason for that. This particular one that I'm going to build, I want to install it in a case that won't have very much clearance over the top. And this cap, as you can see, is quite tall. It's a very, very, very high-end capacitor, and important to making sure that this driver works correctly. So if I installed it upright, it would be there would be, you know, not a lot of room there, so I'll probably install this one at an angle. And then I will have some lead length so that if I do make a mistake or if that one dies for some reason, I can always clip it off and move it. And that's the reason why I was advising you to leave some lead length there. Two things, actually. First off, when you're soldering here, you're not melting the component there because there's a little bit of lead where the heat can dissipate and not be so hot on the component itself. And also, if you have a problem, you can always just clip the component off from the wrong location and put it in the right location because you still have some lead length left. So I recommend that whenever you're putting these in, you put the leads in, solder one lead, stop and check the positioning to make sure that it's right, and then solder the other lead. And you should always work from the inside of a board towards the outside edge and from low components to high components, because if you solder in the high components on the outside edge, then it makes it very difficult to solder in the low components on the inside of the board. It's always best to start with any surface mount components first, since they are certainly the lowest, and then work up from there. Okay? So, in keeping with that, we're going to start off with the two surface mount resistors, which remember were taped on the inside of our bag. We had quite a lot of difficulty people losing those, so that's why we did that. And a lot of people get nervous, and I understand that when it comes to doing surface mount components. They're really not as hard as most people think, and one of the nice things about this kit is that you can use it to build a little bit of self-confidence. Now, the important thing with surface mount components is that there's no lead to hold the part in place before you solder it. So what we do is we just make a tool here. I'm not sure I can get that in a camera. I'm just using a pair of vice grip type pliers to hold a screwdriver. You can do it that way if you want. You can also just take a regular pair of pliers like this and wrap a rubber band around the handle to hold them closed on a screwdriver or any other thing with a tip. Sometimes you can find a component that or a tool rather, that naturally has a point, so you could use this to hold it down as well. But the idea in any of those cases is just to have something that you can place which will put a little bit of weight on the component and keep it from moving while you solder it in place. Okay? So I'm going to fumble through soldering down one of these. Let's see, we'll peel back the tape. It's holding it onto the bag there. There we go. And it's in this little plastic tray. Be careful, they can fall out the sides of the tray. Oops. So what we'll do here is just peel back the plastic over the top, he says. Sometimes easier said than done. There we go. So there's a little plastic cover there on top that gets peeled back, and then you can just dump them out on your work surface. Okay? Take this and throw it away. So now to solder this on, what we do is just take the resistor and place it in the correct location, which is right here between the two pads. I'm kind of OCD, so I like to make sure that they're upright. Okay. And then we're going to take this little screwdriver tip and use that to hold it down in place while we grab our solder and our iron and solder this down. Now, a quick word about my soldering iron here. It comes from England. It's an extremely old isotip wall clipper. It was actually built in Sterling, Illinois, but it was built under contract from the wall company in England. So I'm going to put a little bit of solder down here on the pad, and then I'm just going to gently move the iron over until I'm touching both the pad and the resistor, and get a nice little flow of solder all around that end of the pad. And we're done. Okay. Now we do that on the one resistor, soldering down just the one side of it. We don't need to solder down both sides of it right now. Always solder down one side, and then check your positioning, and then move on to the other one. In this case, I'm going to go ahead and solder down one side of both of the little surface mount resistors. There we go. Get nicely in place. And again, we'll start on the pad with the solder first, and then just kind of flow it up to the resistor itself. Wow. And I have not eaten today, so you'll see my hand shaking. But hopefully that will point out to you that even an old shaky guy like myself can solder down surface mount parts without too much trouble. At that point, we don't need our little hold down anymore, so we can put those tools away. And we can go ahead and solder down the other side of the surface mount resistor. Again, we just want to start on the pad. Once that wet's on there, go ahead and bring it into the resistor itself. Okay? Start on the pad, bring it into the resistor. Okay. So the way I work with soldering irons, and other people have their own methods, and I'm not going to say that one is right and one is wrong, but what I like to do is turn the temperature control. My little soldering iron has a temperature control right there. There's a little special tool that goes in there to adjust the temperature. I turn it all the way up, as hot as it can possibly go. And then what I do is I don't stay on the component for very long. Get on, get your solder to flow everywhere it needs to flow, and then get off again very quickly. I probably spent more time on those surface mount pads than I would normally do. Now there are some issues with the resistors here on the two different versions of the board. Okay, this is a version 1.1 board, which is the one that we're currently sending out. On the Rev 1.1 board, the error LED resistor, which was originally R36, is now labeled R7 on the board, and it is the 4K7 or 4.7K resistor. Okay, so we're going to find our 4K7 resistor right here, pull it out from the tape, and then we're going to find R7 here on the printed circuit board right here, and that's where we're going to put it in. Okay, and you can put your resistors in however you want to. Doesn't really matter as long as they get in there. And again, I very much advise don't push it all the way down flat like that. Take it and push it up a little bit, just so there's a little bit of height, and then kind of put one finger against it, pushing slightly down in order to hold it in place, and then just bend the leads out at that location so that when it falls back, it wants to be there, a little bit up. Okay, I may have overdone it slightly on this one, but the idea here is that there's a little bit of lead left in case something goes wrong and you need to replace the component. Okay, so that takes care of the special R7 on that particular one. The R2, which is right over somewhere else, is not used. This one, R2, is not used, and R1 is not used. Those are for the... there's an option here, which is not supplied and not recommended, where you can put in a power regulator right here in these pads. And if you do, then you have to use those two resistors to set that up. Okay? So, moving on. What we've done here is set up the board with the value of the resistor printed on the board rather than a reference number. So for example, the 47K resistor is going to go right here where it says 47K. Okay? So you can see right there 47K. So we take this guy out, bend the leads, and insert. Set our spacing. Set our spacing. There we go. Okay. and then bend the leads out to hold that spacing. And being overly finicky. Okay, so that takes care of that one. The 2K7 resistor. Now be careful because there's a 2K2 and a 2K7, so you want to make sure that you get the 2K7 is right here. Same thing. Fold the leads. Put it in there. Now you'll notice that I'm not even looking at the color codes. Again, I've found just so many problems with trying to use color codes to actually read resistor values. It's confusing. I may be a little teeny tiny bit colorblind. That's possible. Some of these resistors sometimes came as cut tape, so they'll have a little piece of tape on the end that you want to pull off and remove before you attempt to assemble them. Should be fairly obvious. But I have to have something to talk about while I'm doing this. Okay, so this was the 2K2, right? Okay, good. 2K2 is right here. Here we are. Okay. The 460, which only measured 460, goes right here where it says 470, because obviously that was supposed to be a 470. It's not a critical value, so we don't have to worry about that. Low tolerance resistors, cheaply made in China or somewhere, I don't know where. And now a 330. Which goes where? Oh, okay. That's R1. Yeah. So that is a low value resistor, which is absolutely doesn't matter, but it's right here as R1. I think I previously said that R1 isn't necessary or supplied, but I was wrong. I lied. So that's what happens when you read the directions, is that you find something that you had forgotten about. Even though I wrote the directions, I had forgotten about that. And I will leave that in the video just so that you know sometimes it's best to just stop and read the directions, because there will be something written in there that makes a difference. Okay? So now that I've got all of those kind of more or less on there, what I'm going to do is kind of set this board up on something. And of course, it would be good to have something to hold the printed circuit board while you're working on it, but I just want to show you that you can do it with just very basic tools. You don't need to have fancy tools. As long as you have something, you can get it done. Okay. And again, I always recommend that you do one side of the component and then stop and go back and, ouch, that's hot. Take a look and make sure that it's okay before you continue on. Boy, that was horrible. Okay, so there's a good case of something that went wrong. I got way too much solder on that. I got a nice big blob. How do you take care of that? Well, what you do is you just heat it up like this. You just heat it up like this, and then you whack it. And what you'll find is that the bulk of the solder will fall off onto the paper, which is just fine. Okay? Oh, I see why it's doing that. It's bridging over because there's actually a trace there. One of the things you might want to do is actually just hit it against something that's a little bit harder, like the wooden edge of a desk. Can be very nice for that. You kind of hold it up in the air, get it hot so that it's ready to go, and then whack it like that, and you'll get the excess solder to fall off, and then you can go back and just retouch the lead. Okay, so now at that point you just check the positioning of it and you go, oh geez, I don't like that, that resistor's way too high. Okay, so we will melt that lead, and just being very careful with our fingernail so we don't kill ourselves, we will push the resistor back up, or maybe we will use a pair of pliers. So at this point, if anyone is wondering how it is that somebody this clumsy has ever actually soldered anything together, I can just say, oh well, I'm just being clumsy and a doofus to show you that any idiot can solder these kits together. Right? That's my story, and I'm sticking to it. Ouch. Hey, guess what? The board gets hot. Wow. Really should have done this after dinner. Yeah, good enough. So not going to worry about it. Make sure that your tip on your soldering iron stays clean. Use solder tin on a regular basis, and all will be well. Okay, what are we doing now? Okay, we're adjusting the positioning of those so that they are ready to solder as well. And we will just go in and get the edge of them. There we go. That's much better. So what we want to do is get on, get off. Make sure that they're positioned more or less correctly. Get on, get off. Okay. Check everything and make sure it looks pretty good. Oops, that's a cold solder joint. I didn't get on the pad. Come on. There we go. That was way too long to stay on, but that's okay. It's just a resistor. We're not going to kill a resistor doing that. I'm just going to set that one low. Okay, and now we'll go through and solder the other side of each one of these. Or not. Okay, now when something goes wrong like that, I couldn't get the iron to wet really well, just come off of it for a second and come back later and finish it up. Don't just keep pounding away at that particular part. Go ahead and take a little bit of a break, let the component cool down again, and then come back and try again and get it the second time around. Okay, let's see that. For some reason my iron is not wetting terribly well. I think I need to clean the tip a little bit more. Okay, where have I not soldered? Okay, there. Not the most beautiful soldering work I have ever done. But it will be okay. Okay, so once you have all of those taken care of, we go through and just clip off the leads. Now, I always save the leads that I have because we use them as jumpers later on. And as you can see, I'm in the habit of doing that, so I probably have more than... Okay. And there's a couple of different options for this variable resistor. The way it's marked on the board is to take the output part of it right there. See, this is the back, and then there's the part that you're actually going to adjust. And it just drops in here like this, so that it's accessible from the outside edge of the board. The other option, and it's the one that I'm going to use today, is to put it in like this, and then fold it down and push it over like that. It does hang just a little bit off the edge of the board there, as you can see, but I like being able to adjust it from the surface, and because of the way that this particular one's going to be mounted, I'm going to want to be able to adjust it from the top down, not from the side in. So once that's taken care of, let's go ahead and flip it over and solder the leads. Okay, always solder one lead, check positioning, solder the other leads. On the off chance that it's unclear, the reason why we're doing that is because once you've soldered the second or following leads, there's no way that you're going to be able to Okay, so we've just soldered down this little adjustment resistor, current adjust resistor. I chose to solder it down, turned down like that. You could also solder it in the other way. Moving on, now we're going to do the capacitors. Now, the trick with the capacitors is that it's very difficult to read the value on the capacitor. It's extraordinarily tiny. I'll zoom in as far as I can. I don't know if you can see that, but that says 104, and that's all of these in this strip will be the 104s, and then these little guys here, the 3, will be, I hope, the 101s. Let's see if I can get that to focus in. Come on. Yep. There we go. I don't know if you can see that. It's very, very, very tiny writing. If you have a meter that's capable of measuring capacitance, I would very much recommend just doing it that way. But also just know that these guys are going to be all the 104s, and the 3 are going to be the 101s. Okay, so the 104s then, these are, so it's a 1 and a 0, and then 4 more zeros. So 104 means 1 0 and 4 more zeros. So that's the 100 nanofarad or 0.1 microfarad. So that's the 100 in is how it's marked on the printed circuit board. Okay, so you'll see in a number of places where there's 100 in or 100p, like for example right here, marked as 100 in, and then over here 3 times 100p. Okay, so what I like to do is, since these are the 101s, which is a 1 and 0 and then 1 more 0, or the 100 picofarad capacitors, I like to go ahead and do all of those at once, because they're all right next to each other right in that line. Makes it very easy. Go ahead and bring them up a little bit, and then just bend out the leads. Whoops. Make sure that they're all hanging more or less at the right height. Solder down one side. Check the position. Now that last one could come up a little bit if I wanted to be OCD about it, but not that much. Come on now. Okay, there we go. That's about right. And then we'll go ahead and solder down the other side. Come on, get onto the pad. And I want to make sure that those are generally okay. Go ahead and clip the leads. Yeah, good enough. Okay, now all the rest of these go wherever else there are capacitors. You can just pull these out of the tape this way, but it's kind of a pain. It's difficult to do. I generally find that it is slightly easier if you can peel the tape back from the cardboard, which honestly isn't all that easy either. Wow. Yep, it's going to be one of those days. There we go. All right. So now again, these are all the 100 ins. So wherever you see a 100 in on the board, we know that we can put these in. And of course, because these are just the little ceramic disc capacitors, the orientation of the pins doesn't matter, just like with the resistors. It doesn't matter which way you put them in, as long as you get them in there. I may just cut out this part of the video because by now this should be incredibly boring. And I want to make sure that we do have your attention for the parts that are actually somewhat important. Primarily that error LED does not get installed where sometimes you might think it would get installed. So we want to be very careful to make sure that that is explained well. Here we go. Right up next to the chip where it should be. This, by the way, is an absolutely brilliantly well laid out board. Luc de Grand did a magnificent job of laying this one out. Very impressed with his work here. In any kind of a power electronic circuit, it is very difficult to optimize everything as much as possible for the distance of things like capacitors, especially from the point where the power needs to be most regulated. And Luke just did a fantastic job of working out how to get everything to as close as possible to where it needed to be. You know, typically when you're laying one of these things out, you get one thing right where you want it, and then you find out that there's another component which also has to be right next to something, which means that you can't put that first component where you want it to. So in other words, the two conflict with each other. Okay, got all of those soldered down. They look more or less okay. And we will go ahead and solder the other lead. So Luke came up with some very, what I think are clever solutions to some of those problems and managed to really get everything down in the minimum space possible. Oops, that was a cold solder joint. Wow. Boy, I hope no prospective employer ever watches this, because I am just not doing well on soldering today. Okay, what have I forgotten? Ah, just this last one here. Come on. Okay, and we're clipping leads. And let's go on and do the, oops, I missed the capacitor. Okay, where do you go? Ah, here it is. Put 100 in right here by the edge. That one's easy to miss because the little jumper header that goes right there has exactly the same kind of pin spacing. So you look at it and you think, oh, that's just another part of this, but it's not, it's separate. Okay, onwards and upwards. Network resistors. Now the trick with the network resistors is that they have a little dot on one end. It is very tiny and very difficult to see, but hopefully, if I can get the camera to focus, come on there, old girl. Hopefully you can see that right there on that end, there's a little dot, okay? It's not there on this end. It's only there on that end, okay? And that goes into the square hole where each one of the resistor networks is. So, for example, you'll see here RN2, And you'll notice that there's a square hole on that pad right there. You can see it. So this will go in this way. Okay. And what we do is just snick out the outside leads so that it holds it in place. And we will do the same thing with these two. First finding the little square, a little dot rather. Come on, focus. Okay, where are you? Nope. Good grief. I have to get out a magnifying glass to see this. Oh, there it is. It's on this end. Okay, so here is RN1 right here. There's the square pad on that end. I'll go ahead and drop that in right there. And snick over the outside leads so it doesn't leave us. One more, which goes right down here. And there is the little circle on one edge. So that goes in the square pad right there. Okay. And again, what we want to do is go through and solder just down one pin on each one. So I always start with the square pad. I'll solder down the square pad only. And then come back and check everything. Make absolutely certain that I got it right. Okay, there's the little hole, or the little dot. It's on the square pad. I got a little dot right there on the square pad. Alright. Little dot right there is on the square pad. And just going to set these up so that they're through the board nicely, evenly. Alright. Then we'll just go down and solder them. Now, if this were some other component other than a resistor, which I know I'm not going to burn up, I would recommend not going down the pads one at a time, like I'm doing here. The actual proper technique is to bounce around, go and hit one pin and then go on to another component, and then come back and hit the next pin and go on to another component, do its next pin, and so on and so forth until you're all done. The idea there is to not let the heat build up in the component too awfully much. Wow. A heck of a time with this iron. You know, the soldering typically goes much easier with a more professional soldering iron. This one is one that I love for personal reasons. It was given to me by my father. But it really is not that high quality in iron. It's not. It's not certainly a professional soldering station. It is temperature regulated, but as I said before, I've just turned the temperature all the way up because that's what I find works best. And a quick little visual inspection there, make sure that everything's got. Alright, starting to take shape. We're done with the resistors, the variable resistors, the network resistors, the capacitors, and now we will do the LEDs. Okay. As with other components, the long lead goes in the square hole. The green LED here is just a power indicator. It's actually optional. You don't have to include it, but I think it's very good to have something on there that just tells you that, hey, the board is fired up and working. And it goes right here where it says 5 volts. Not sure if you can see that or not. And one of those pads is square, the other is round. the long lead goes in the square pad. Okay, and especially on a component like an LED, I strongly recommend that you not install it like that. You want to install it a little ways up so that you don't melt the component while you're soldering it, and so that if I was wrong and I put it in the wrong place, I can move it, or if for some strange reason it burns out at some point in time in the future, you can easily clip it off and repair it. Okay, and again with those, you want to get on, solder it, get off. That takes care of our power LED, and now the little error LED, this is a confusion for people, which I certainly understand. The red LED, there are two different options on the board. One option is just to have an error LED, and that then goes right here where it says Q1 error. It does not go here. It does not go here where it just says error. It doesn't go back to the power LED. It goes over here. And on this particular one, the red LED should be installed between the error and Q1 labels, the long hole in the square pin, as always. So there's the square pad, rather, not pin, pad, and we're putting the long lead in the square pad. So it goes in just like that. I hope you can see that nicely. Okay. So while I'm soldering this down, let me just explain the reason why this was done this way. The chip that we're going to be using here, the THB6064, for whatever reason, does not have a very strong driver for the error LED. The pin coming out of the chip that indicates an error can only handle a very small amount of current. It just doesn't have the capability of driving an LED big and strong like that. So what we do is we put a very high value resistor between the LED and the chip, so that the LED won't pull too much current and damage the chip. That's great for just a general error LED. We've got a really high efficiency red LED here so that you will be able to see it if there's an error. It won't be too dim, and we can use a higher value resistor to limit the current. Some people, though, really want to have an error signal come back out of this connector and back into their motion controller to let the motion controller know that something's wrong, that it's over-temped or whatever. And in that case, then what we can do is you can put a transistor in that location, put a smaller resistor in one of the spots over here, I think, and then put the error LED here, and it also connects to a wire that goes back. And you'll get a very, very bright error LED, but more importantly, you get the signal going back to your motion controller. So that's why there's two different places labeled error. Okay, terminal blocks. So the terminal blocks then, they have a little rail down the side and a little groove and a rail here. And the way this works is, well, hopefully you can see that. There we go. So the way this works is that you set it up like this, okay, and then you slide it together, he says. There we go. And it's pretty stiff. You really have to push on it, okay? But what that does is it makes it a 6 in-line block instead of just 3. And those, of course, go right here, right on the back of that resistor. Just make sure that it's going to be on there all right. Looks good. Okay, now this is really one where you definitely want to solder down only one of the pins. Very important to do it in this particular case. Okay, solder down one pin, because what you want to do now is you want to press on the thing and remelt that pin so that you can make sure that you really have it nicely mechanically seated down to the board. Okay, now that it's held in place, correct location, all the way seated, you can go ahead and solder it down the rest of the way. And on these I'm going to bounce around a little bit because I have actually had the plastic melt once before, when I was doing this. So I'm just going to bounce back and forth and not do it in a line. Wow. And it was such a difficult time getting this iron to wet to the pads. I don't really understand that. Okay, have I melted the plastic yet? I was on there for a good long time. Here we go. Okay, I don't know what was going on with this one, but it just definitely did not want to go. Alright then, that looks alright. So now the jumpers, these guys right here, they do not go here. Be very careful about not soldering that in there. It's the wrong place for it. They go over here. And drop in just like that. What you probably want to do is just set that on something. Again, solder down one pin. Check your positioning. What you can do is push here and remelt that pin. Whatever you do, don't put your finger like that and then remelt that pin. Okay, that's going to hurt. How do I know that? From all the times that I've done it. Okay. So now on this one, there's a lot of metal and very little plastic. Just that little teeny tiny bit of plastic right there. And you can definitely really melt that plastic if you're not careful. So I would definitely recommend that you kind of bounce around and not go right down the row on these. You kind of want to give it a chance to cool off before you do the next one. God, what is going on with this iron? Okay, can we get them all? Looks alright. So that's our jumper block for our options. The options are printed right here on the back of the board, and of course they're also in the manual. So for example, where it says J1 and J2 control the decay, right? So then if you look here, right on the edge, I'm not sure if you can see it, but this is J1 over here, and then J2, and then J3, and J4, and J5. So they're a little bit backwards. They're not 1 to 5, they're 1 to 5. Okay? Alright. Now, jumpers. There's one last little shrouded set of jumpers. Notice that there's a notch right here in the middle of the shrouded jumper, and on the board you'll see that the silk screen has a little notch right there. Okay, so it goes this way. Let's see if you can see that or not. It goes that way and not the other way. Very easy to melt these, so don't stay out on a long time like I just did there. Make sure that it's positioned nicely, and then bounce around as you're soldering it down. Really having a time wetting. You know, I think it's the board actually. I should have probably cleaned it a little bit before I started doing this. I generally have not had that problem with these boards. They're actually very well made. But I think this one I may have handled too much. I was showing it around to people, and I probably caused the pads to get a little bit corroded on it. You can correct that by just very lightly or gently sanding the top. You don't want to sand so much that you take off the solder mask or the protective coatings, but you can sand it just a little bit in order to scuff up the pads. Very light sanding paper. We're talking about like a 300 or a 600 grit, something like that. Okay. What are we missing? We got our power capacitors yet to do, and then the big chip. So here's our medium power capacitor. Again, long lead going into the square hole right there. And this is marked as a 10 microfarad, which I believe is what we supply. Yeah, 10 microfarad. Hopefully you can see that right there. Well, you could if the camera would focus on it. 10 microfarad. Going right here in the hole for the 10 microfarad, the long lead, into the square pad. There we go. I'm going to let that come up just a little bit. Again, because it's a large component, I'm not gonna give myself as much lead as I normally would. Yeah, it's funny, some of these, the pad, just barely touch it and it wets and everything's fine, and others, it's like very difficult to get it to wet to the pad. Okay. That takes care of that. And then we'll go ahead and do our big power capacitor. Now, actually, I may not put this on here yet. Yeah, I'm not going to put it on yet because I want to solder on the chip first and then solder this in place before I go ahead. And let's see. Yeah, it will just fit down there between those two caps out of the way. As I've said, normally you would install this upright. I'm just doing a little bit of a special build here because the way I want this done. Okay, so we're going to leave that for later. I'm going to go ahead and solder on the chip. Now, what you want for this particular device is, if you're going to be using it at anything near its rated current, you want to use a nice heatsink. This is I believe it's a socket 370 CPU cooler, somewhere around here. I don't see it handy. I have the fan that actually mounts onto this, and the one that I sell is very similar to this, slightly different, but more or less the same. And what I've done here is I've gone ahead and marked out where each one of the holes is for the board mount, which would be right there, and for the chip to mount on, right there and right there. Okay. So normally what we would do is I would go ahead and drill this first, tap it, and get my mounting hardware together. A little bit of solder paste to put under the chip. I would do all of that first, and then what I would do is I would position the board, position the chip, screw them in lightly, and then I would solder a couple of the pins on the top in order to make sure that the pads exactly match with the pins of the chip. Okay. Unfortunately, my drill is currently out of commission, so I am going to skip that in the video and just show you putting the chip on. Now, the chip is somewhat static sensitive, not too bad. I'm going to solder it on there without a solder strap, If you're in real dry, arid conditions where you have a lot of static electricity, you probably want to make sure that you don't do that. If you look at the chip, you'll see that there is a indented little, come on now. You'll see that there's a little indentation right there, a little hole. I want to make sure that you're seeing that. Hold on just a second here. Okay, see it right there, which is not on this side, certainly not on the back. Okay, so it's just right there. You'll also notice that pin has a slightly wider little thing on it. These other top side pins don't have a, they're just straight. You see how that one has a slight flare to it? That's pin 1. So that goes right on there, like that. Okay? Now again, you would normally go ahead and do this up on your heatsink after drilling and mounting everything. I'm going to go ahead and cheat and just do it like this. You know what, maybe what I can do is I'll just do it to the holes where I've marked them, and then hopefully later when I drill everything will be okay. I've been putting off making this video so that I could get my drill press up and running again, but fortunately have not been able to find the correct parts. Okay, so now that we have that in position, again we just go ahead and solder down one of the pins. Okay, make sure that the positioning is correct. Solder down one more pin. Okay, you notice I'm getting on and off very, very quickly. I do not want to overheat the chip. So we'll go ahead and flip it over and hit a couple of pins on the back side. Here and here. Okay. And the idea there is just to tack everything in place. Okay, now at this point normally you would go ahead and you would have unscrewed the chip and everything once you'd soldered the top 2 pins so that you could flip it over and solder the back 2 pins. Okay, and I am definitely going to not do this linearly. I'm going to do a pad and then run down a little bit and do a pad over here and flip it over and do a pad and a pad. Come back and do 1, 2, 3. And do 1, 2, 3. And this is again one where you really do not want to stay on there for any length of time. You want to get right on and right off. If it doesn't wet or you're having some kind of a problem with the iron, don't just hold it on there. We don't need to use a huge amount of solder here. Just a little bit is fine. Okay, that looks good. Now I'm going to go back and touch up just a couple of these. This one didn't look like it had quite enough solder on it. This guy looks a little weak as well. You don't need a ton of solder, just a bit, but that one was really low. Okay, Very nice, very consistent. And now I'm going to go ahead and put this big electrolytic capacitor on here last. Again, that's kind of special to the way that I'm building this. Normally you would not install it that way. I just want this to not take up very much space top to bottom. Long lead is in the square hole. Solder one pad, check the position. Looks good. Solder the other pad. Oh, come on. Totally strange. Okay. Alright. I'm going to clip the last couple of leads. Now, one last thing, we want to use one of the clipped resistor leads to form a jumper. This is step 9 on the instructions. We're going to short J7. Okay, now let me explain what that is real quick. There is a pin on the PN and MO connector here, which will provide power to the rest of the board. That's J7. I don't know if you can see that right down in there. And that then causes power coming in from your motion controller to be applied to the chip as the logic power. If you leave that off and you install the 2 resistors in the power regulator here, it will pick up motor power and use that to power the chip. I don't recommend that simply because the plus 5 volt power is almost always available from the motion controller. The efficiency of the regulator on the board isn't all that great. It's better to use the power that's coming from the motion controller to take care of this. Probably should have done that earlier, but I'm not smart that way. Okay, so I'm also going to leave that up a little bit on the jumper, and the reason for that is because it's just a great little test point where you can grab on there to see whether or not you actually have power, just in case the power LED does not light when you hook this thing up. Okay. There's one other place where we want to make use of a resistor lead. We want to get a nice long one, and that is we want to make a test point. Now the way we do this is take a thin lead, needs to be like a resistor lead if at all possible, and take a pair of little needle nose pliers like this and pinch it back around like so. I don't know if you can see that, but what we've made is a little, like almost a pin with the head on the top of it like that. And then we go ahead and put that in the VREF hole, which is right here. Let me show you that. Right there on the board. Come on, focus. Focus, see where it says VREF? Now we're sticking both sides of the lead through that VREF hole, which is why it needs to be a fairly thin lead. Come on, get in there. Okay, and we want to turn that so that it's easily accessible. Now that's where you're going to attach with your meter or whatever to measure the VREF value when you're adjusting it for use. Okay, that is the officially correct way of doing that. Where are we? Here we are. Now, just between you and me, it's not like this is being videotaped or anything. What I always do is just turn VREF all the way down, hook up the motors, and then start turning it up until I'm happy or it errors out. Horrible. Horrible. Don't do that. You didn't hear that from me. You should always set it correctly according to the directions. Okay, so that takes care of the jumpers. That takes care of the test points. Now let's go back over and make sure that I did everything I was supposed to do. Okay. I have the surface mount resistors on there. I have all of the regular resistors in place. I used a multimeter to test them. Okay, R1 is the correct resistor, okay. The error LED resistor, R7, is the 4K7. It's installed in the correct place. R2 is not used. R1 is. The variable resistor is installed correctly. The network resistors are installed correctly. The little capacitors, the big capacitors, the LEDs, the terminal blocks, the jumpers. J7 has been shorted, so I'll get power from the connector. And we made the test point. Okay? So at that point, everything's finished. The next thing to do is to go ahead and add power to it by connecting it to the motion control board. So this is a single axis ribbon cable, which hooks here onto it, and then we hook up to our multifunction board. Now this is a multifunction board that has been built out as a tester. So I'm going to go ahead and hook that up to this. This should be the X. Okay. Here we go. Oops. Oh, this way. And I'm just going to power this off the regulator on this board, which goes this way. And when I plug this in, oops, when I plug it in correctly, good lord, you get a very nice green power light, and nothing appears to be overheating. I will now adjust VREF, as I indicated, all the way down. I believe is that direction. We'll check that quickly with the meter, just to make absolutely certain. A nice ground connection where, yike, there. And if I can get on my VREF point, uh-oh, no, see, I went the wrong way. Okay. There we go. So we want to turn it all the way to the right in order to be at the lowest possible power. And then we will go ahead and hook up a stepper motor to it. But we will wait until I have a heatsink to do that. So hopefully that'll get you far enough in the assembly of this unit to know how to do what you want to do. Okay. Oh, I forgot the jumpers. Option jumpers. Okay, so normally what you would do is go through and put on whichever of these little option jumpers you decide you want. This little part right here goes on the outside, the smooth part goes down, so that makes it a little bit easier to take them back off again if you want to. I would normally start with all of the jumpers off, actually, to do the initial testing, in order to just verify that it's working okay in the most basic possible mode, and then start adding jumpers to increase your microstepping and to fine-tune the decay. I've never had a reason to change the decay. I've always left it unjumpered, but you may find that when you're pushing the board right to the very limits, and with certain motors it might be better to jumper it. Okay? Alright, that's it for now, folks. Thanks much for watching.